source of excitement in the scientific community is the launch and commissioning of the James Webb Space Telescope. As the most powerful and expensive telescope ever, it's understandable that expectations are so high. However, can the JWST live up to these expectations? Scientists got an early answer to that question with the terrifying discovery the Space Observatory has made on Jupiter. What has the most powerful telescope in human history found on Jupiter? Has it finally spotted aliens on this massive planet? Should you be concerned about this discovery? Make sure you watch this video to the end as we bring you James Webb Space Telescope's terrifying new discovery on Jupiter that changes everything. The entire world gasped in amazement and shock as the first James Webb Telescope photos were made available to the public this year. Every little detail in these photographs, from merging galaxies millions of light years away to planets outside of our own Milky Way, captivated people all across the world. Even scientists were perplexed by the novel and perplexing facts that the James Webb Space Telescope's initial data set revealed. This incredible telescope has given us a wealth of knowledge about our universe in less than a year that has fundamentally altered the way we view it. It stands to reason that a telescope that can see galaxies billions of light years beyond us and light from the beginning of the cosmos would have no trouble giving us highly detailed photos of our own solar system. The James Webb Space Telescope has once more demonstrated its excellence by sending out some mind-blowing photographs of Jupiter, the king of planets and the largest planet in our solar system. Jupiter is the solar system's largest planet and the fifth planet from the Sun, and there is a long, colorful history of the gas giant shocking scientists. This king of the planets is a stormy enigma covered in vibrant clouds and named after the type of gods in Roman mythology. The Great Red Spot, its largest and most renowned storm, is twice as wide as the Earth. Galileo's 1610 discovery of Jupiter's four huge moons, Io, Europa, Ganymede, and Callisto, helped redefine how we view the universe and our role within it. The Copernican theory that the Earth was not the center of the universe was validated by these discoveries, which marked the first time celestial bodies were spotted circling a body other than the Earth. NASA estimates that Jupiter is more than twice as massive as all the other planets in the solar system combined. The enormous size of Jupiter could accommodate more than 1,300 Earths. Earth would be the size of a grape if Jupiter were the size of a basketball. Because it was created from gas left over from the birth of the Sun, Jupiter was likely the first planet to form in the solar system, and the planet would have grown into its own star if it had been around 80 times more massive during its formation. Jupiter's orbit takes it 483,682,810 miles from the Sun on average. This distance from the Sun is 5.203 times greater than the standard Earth-Sun distance. Jupiter's atmosphere, which is primarily formed of hydrogen and helium, is similar to that of the Sun. At the center of the planet, a fuzzy or partially dissolved core is encased in a fluid metallic hydrogen layer rich in helium. According to researchers at the University of Colorado in Boulder, Jupiter's enormous magnetic field is the strongest of all the planets in the solar system, being about 20,000 times stronger than that of Earth. The planet's moons and rings frequently experience radiation levels more than 1,000 times higher than those that are harmful to humans due to the magnetic field's extreme trapping of electrons and other electrically charged particles. Even heavily insulated spacecraft, such as NASA's Galileo probe, can be harmed by the radiation. The James Webb Space Telescope mission was launched in December as a joint effort by NASA, the European Space Agency, and the Canadian Space Agency. The Webb Space Telescope is the largest and most powerful one ever created. At this time, the James Webb Space Telescope is orbiting the Sun roughly 1 million miles away from the Earth. The 10-year anticipated mission of the telescope means that many more fascinating photos of our solar system are starting to be revealed. Galaxies so far from Earth that cosmic expansion has pushed their light deep into the infrared region of the spectrum, which the telescope is meant to detect, have already been photographed by the James Webb Space Telescope. Additionally, the observatory's near-infrared spectrograph, NIRSpec, made the first unambiguous discovery of carbon dioxide in a planet outside of our solar system when it found the gas in the atmosphere of exoplanet WASP-39b. But JWST has also focused on areas that are nearer to home. Astronomers used the strong infrared eyes of the telescope to focus on Jupiter on July 27th. Images obtained as a result show a planet that is both known and unknown. We've never seen Jupiter like this. It's all quite incredible," said Principal Investigator Imke DeParter of the University of California, Berkeley in a statement. "We hadn't really expected it to be this good." Images captured by the Webb telescope now show its massive storms, auroras, and faint rings in greater clarity. Several photos from the telescope were combined to form an overall composite and show the gas giant on Earth. As a result, the color of the image changes, moving from orange and yellow near Jupiter's poles to blues and purples in the center. According to NASA, distant galaxies and thin rings may also be visible, photobombing in the foreground. The images are so astounding that even NASA's own experts were reportedly surprised. Jupiter appears to have vivid aurora around its poles and is coated in white streaks and spots. The photos are substantially more colorful as compared to the Hubble telescope, to which the James Webb telescope is a direct successor. Together with Thierry Fouché, a professor at the Paris Observatory, DeParter directed the observations of Jupiter as part of an international undertaking. "It's simply outstanding," DeParter continued in the press release, "that we can see details on Jupiter together with its rings, tiny satellites, and even galaxies in one view." The first collection of full-color images and data taken by the Revolutionary Telescope, which NASA released in July, showed a glittering cosmic extravaganza of clashing galaxies and a dying star. The two views of Jupiter were captured by the telescope's near-infrared camera, which uses infrared filters to highlight the planet's intricate features. In order to highlight Jupiter's features and transform infrared light, which is undetectable to the human eye, into the visible spectrum, the images were digitally colored. The information from telescopes like Webb doesn't come in a tiny bundle to Earth. Instead, it includes details regarding the intensity of the light detected by Webb's detectors. The Space Telescope Science Institute, STSCI, Webb's Mission and Science Operations Center, receives this data as raw data. The data is calibrated at STSCI and sent to MAST, the Mikulski Archive for Space Telescopes, for dissemination after being processed. Then, throughout their investigation, scientists convert that data into pictures like these. While staff at STSCI formally prepares Webb photographs for publication, citizen scientists or amateur astronomers frequently go through the public data library to retrieve and process images as well. These fresh-release pictures of Jupiter were analyzed by veteran citizen scientist Judy Schmidt of Modesto, California. She worked with Ricardo Hueso, a co-investigator on these observations, who researches planetary atmospheres at the University of the Basque Country in Spain, to create the image that shows the tiny satellites. Schmidt asserts that Jupiter is more difficult to work with than more distant celestial wonders. That is due to how quickly Jupiter rotates. Additionally, it can be difficult to combine a stack of photographs into a single view if Jupiter's distinguishing features have rotated since the images were acquired and are no longer aligned. Additionally, to arrange photographs logically, she occasionally needs to make alterations digitally. Jupiter is a gas giant unlike Earth and lacks a solid surface. Its primary constituents are hydrogen and helium. It is said to have the same basic elements as a star but was never big enough to burst into flames. It also has numerous rings, however they are dimmer and made of space dust as opposed to ice like Saturn's rings. The new images provide a wide-field perspective of Jupiter, its two tiny moons, Amalthea and Adrastea, and its faintly visible rings. One of Jupiter's 53 named satellites, Amalthea, is the fifth largest overall, and the first to have been found after the 4 Galilean moons. Amalthea is the third moon closest to Jupiter, and it completes a full orbit in under 12 hours. The last planetary satellite in the solar system to be found directly or by using a telescope as opposed to an imaging tool like a satellite or probe was Amalthea. With regard to the moons of Jupiter, Amalthea continues to be rather mysterious. We don't know much about Amalthea with certainty because there haven't been many in-depth observations. We are aware that it's a rocky body with a mean radius of approximately 51.88 miles, 83.5 kilometers, as determined by NASA. It has a potato-like shape. It belongs to the inner moon group with Metis, Adrastea, and Thebe, and orbits Jupiter at a distance of 112,717 miles, 181,400 kilometers, in 11 hours and 54 minutes. Amalthea has a temperature of 155 Kelvin based on infrared photometry. The moon features hills and valleys and is dotted with impact craters according to observations made by the Galileo orbiter in the 1990s. The largest, Pan, is gigantic in comparison to Amalthea's size, with a circumference of 55 miles 90 kilometers. It is the reddest object in our solar system, and scientists think the hue might be caused by sulfuric chemicals from the adjacent volcanically active Jovian moon Io. The Amalthea Gossamer Ring, Jupiter's faintest, innermost Gossamer Ring, is one of the Gossamer rings that Amalthea contributes. Outside of the main Jovian ring are the Gossamer rings. Amalthea mysteriously appears to radiate more heat than it takes in from the Sun. NASA hypothesizes that this may be because of Jupiter's magnetic field or tidal forces. Amalthea always aligns with Jupiter along its long axis because it is tidally bound to the planet in synchronous rotation. Only 2 missions have ever visited Amalthea before JWST made its most recent discovery, Voyager and Galileo. The Jovian moon was captured in images by both the Voyager 1 and Voyager 2 spacecraft during their flybys in 1979. Then at the beginning of the 21st century, the Galileo spacecraft used its solid-state imaging SSI experiment to take pictures of Amalthea, providing additional information about the peculiar moon. This single image can serve as a summary of our Jupiter system program, which investigates the dynamics and chemistry of Jupiter, its rings, and its satellite system. However, Webb does not simply discuss Jupiter. The infrared radiation from the Space Telescope illuminates areas of the cosmos that were previously hidden. Combined with the deep field images released the other day, these images of Jupiter demonstrate the full grasp of what Webb can observe, from the faintest, most distant observable galaxies to planets in our own cosmic backyard that you can see with the naked eye from your actual backyard, says Brian Holler, a scientist at the Space Telescope Science Institute in Baltimore who helped plan these observations. There is unmistakably a dark spot on the planet's left. This is Europa, one of Jupiter's Galilean moons, and a key object in the search for possibly habitable habitats in our solar system. We will come back to this. More excitingly, a different NIRCam image provides a clear look of Jupiter's rings. There are rings on Jupiter, and the Webb telescope has been able to clearly identify these distinguishing features. The most recent images also show Thebe and Metis on Jupiter. Jupiter images taken using narrowband filters provide stunning views of the planet's whole disk. A true and very welcome surprise, however, was the availability of additional information on extremely faint objects, Metis, Thebe, the main ring, and hazes in those images with approximately 1-minute exposures. The most recent images also show Thebe and Metis on Jupiter. The images also display Jupiter's well-known Great Red Spot, which, according to NASA, appears white because it's reflecting sunlight. A storm that is bigger than Earth and has been raging for a very long time is called the Great Red Spot. And directly to the left of Jupiter's Great Red Spot, a white blob, is a black spot. That is the shadow that Jupiter's cloud tops are being thrown by Europa. The JWST team is optimistic that future observations will enable the Space Telescope to identify similar events on Europa. For instance, the Saturn-bound Cassini spacecraft was able to spot material plumes emerging from the moon Enceladus's deep ocean. At a distance of 9.7 million kilometers on December 30, 2000, Cassini made its closest approach to Jupiter and gathered an abundance of scientific data. Approximately 26,000 images of Jupiter, its hazy rings, and its moons were taken during the 6-month flyby. It produced a global color image of the world, the smallest viewable elements being about 60 kilometers 37 miles across. One of the major findings of the flyby, which was made public on March 6, 2003, was the atmospheric circulation of Jupiter. Since many clouds on Earth form where the air is rising, scientists have long concluded that the light zones in the atmosphere with their pale clouds are regions of upwelling air. In the atmosphere, there are alternately dark belts and luminous zones. According to an analysis of Cassini's images, individual storm cells of upwelling bright white clouds can be detected in the dark belts, despite being too small to be seen from Earth. A swirling dark oval of high atmospheric haze that was around the size of the Great Red Spot was another atmospheric feature that was observed close to Jupiter's North Pole. Images captured in infrared light revealed features of circulation close to the poles, such as bands of winds around the entire planet and neighboring bands moving in opposition to one another. The same announcement also contained a description of Jupiter's rings. The discovery of irregularly shaped, as opposed to spherical particles in the rings suggests they were likely produced by micrometeorite impacts on Jupiter's moons, most likely Metis and Adrastea. Previously, the Hubble Space Telescope and NASA's Juno spacecraft found evidence that Jupiter's rapid rotation and the eruption of sulfur and oxygen from volcanoes on Io, the solar system's most volcanically active planet, produce an electric current system that powers the strong auroras seen around the gas giant's poles. Jupiter completes one rotation every 9.5 hours and is more than 11 times wider than Earth. Io, a moon of Jupiter, has more than 400 active volcanoes that regularly erupt lava dozens of miles into the air. Io orbits Jupiter at an average distance of about 262,000 miles, 422,000 kilometers. These emissions form electrically charged material or plasma when they fall into Jupiter's orbit. While Hubble's imaging spectrograph analyzes the intensity of Jupiter's auroras, Juno's magnetic field investigation provides a thorough view of Jupiter's outer plasma environment and the electrical currents flowing across it. The majority of the material ejected from Io is repelled by Jupiter's fast spin, and as the material travels outward, Jupiter's rotation rate slows. Scientists have discovered that Jupiter makes an effort to maintain this material's rotational speed by using electric currents to move through its upper atmosphere and magnetosphere, which is where the planet's magnetic field is strongest. The material in the magnetosphere and the electric current system then engage in an electromagnetic tug of war as a result. The material cycles through the planet's upper atmosphere and mixes with gases, producing vibrant aurora light displays as it travels down Jupiter's magnetic field lines back toward the planet's poles. Discovering this relationship is exciting because it not only clarifies how Jupiter's magnetic field functions, but also those of planets orbiting other stars for which we have previously employed the same theories. And now, with renewed confidence, it also gives us a better understanding of how those magnetic fields operate. However, Jupiter's auroras have never previously been unobserved until now, thanks to the world's newest and largest space telescope. Images of Jupiter's northern and southern lights, as well as its polar haze, were taken by the James Webb Satellite Telescope. On the other hand, a new study reveals that Jupiter's supervolcanic moon boasts expansive, meandering dunes that were formed by lava flows beneath the moon's surface rather than wind. The innermost of the four significant Galilean satellites, Io is the third largest moon orbiting Jupiter. It features a rolling ice surface that has long baffled scientists. Scientists have recently created a new theory for how such dunes might originate, though, using new data. Dunes are ridges or mounds of sand that have been built up by the wind. Io's winds, however, are weak due to the moon's low-density atmosphere, suggesting that its dunes must have originated through some other mechanism. With hundreds of volcanoes, some of which erupt sulfurous plumes hundreds of miles or kilometers high, Io is the solar system's most volcanically active planet. With this much volcanic activity, the surface is diverse, with a mixture of sand, flowing effusive lava streams, and sulfur dioxide snows, as well as black solidified lava flows. In order to replicate the force necessary to move grains on Io and determine the trajectory those grains would travel, scientists use mathematical equations. According to the study, which replicated the movements of a single grain of basalt or frost, showed that the interaction between flowing lava and sulfur dioxide beneath the moon's surface creates venting that is dense and moves quickly enough to create large features that resemble dunes. And the researchers' conclusions are supported by observations from NASA's Galileo probe, which reveal that the spacing and height-to-width ratios of Io's crests are consistent with dunes found on Earth and other planets. Io's surface is also changing incredibly quickly. On the moon's surface, volcanic cracks spew lava, filling impact craters and forming fresh floodplains of flowing rock. Although the precise makeup of Io is unclear, silicate rock or molten sulfur and its compounds are most likely present. In addition, sulfur dioxide dominates the moon's meager atmosphere. NASA's Voyager missions made the initial discovery of Io's volcanic activity in 1979. Strong tidal forces are what fuel the volcanism on the moon. The intensity of Jupiter's gravity on Io fluctuates depending on how near the moon is to the gas giant as it orbits Jupiter in an elliptical manner. Io's surface can bulge by as much as 330 feet, 100 meters, due to this gravitational fluctuation, which exerts a constant push and pull on the moon's interior in various directions. Due to this movement, the rocks on Io grind against one another, producing a heat flux that is 20 times greater than that of Earth. Io's orbit would have likely settled down into a circle a long time ago if it were Jupiter's lone moon, but the ongoing steady tug from Io's outer neighbors Europa and Ganymede prevent that from happening. Io is trapped in this never-ending game of gravitational tug-of-war which causes the planet to heat up. According to ESA, sulfur and sulfur dioxide make up the majority of Io's surface. Along with hundreds of volcanoes, patches of sulfur dioxide frost have also been seen on the surface. The surface pressure of the atmosphere of Io, which contains sulfur dioxide, is a billionth of that of Earth. But do you know the significant impact Io has on Jupiter? Even though Io is very small, around the size of Earth's moon, the moon nonetheless has a significant influence on its parent planet. Because of the way Io's orbit crosses Jupiter's strong magnetic lines of force, it functions as an electric generator. NASA claims that Io is capable of producing 400,000 volts across itself, which results in 3 million amps of electrical current. Then, as it travels back along the magnetic field lines of Jupiter, it produces lightning storms in the planet's upper atmosphere. Io loses a ton of material every second as Jupiter rotates due to magnetic forces. A plasma torus, which is a donut-shaped cloud of radiation, is created when the substance is ionized. Jupiter's upper atmosphere is filled with some of the ions which cause auroras. Hubble's detection of the effects of Io and another Jovian moon, Ganymede, on Jupiter's auroras in 2018 provides an illustration of this behavior. This year, the James Webb Telescope provided additional proof that auroras on Jupiter are caused by the electric current and volcanoes on the moon Io. Observations from the Texas Echelon Cross Shell Spectrograph and the Gemini North Telescope in Hawaii suggest that Io also has a foldable atmosphere. Every day, Io is in the shadow of Jupiter, causing the sulfur dioxide envelope of gas to freeze up. The freezing sulfur dioxide changes back into gas when Io is exposed to sunlight once more. Researchers discovered corroborating evidence of the existence of this phenomenon only after this study, which was the first to observe Io's atmosphere in the dark. Io hasn't received a specific mission, however, a number of spacecraft have passed by Jupiter and observed its moons. The first to arrive was the NASA Pioneer 10 craft in 1973, followed by Pioneer 11 in 1974. The Voyager 1 and Voyager 2 NASA spacecraft visited the system again and took stunning images during their flybys in 1979. We got our closest observations of Io to date during NASA's Galileo spacecraft's numerous flybys of the volcanic moon between 1995 and 2002. On its way to Saturn in 2000, Cassini observed Io during a flyby and investigated it. While no mission is planned particularly to look at Io, other missions like the Juno spacecraft are already near the moon or maybe in the future. This kind of work really helps us to comprehend how the universe functions, and that is ultimately what scientists are attempting to do in the field of planetary science. On the other hand, Europa, the sixth largest moon in the solar system and the fourth largest moon orbiting Jupiter, may have liquid water encased within its icy shell. It is an ocean world with a heavy layer of ice covering it and snow drifting upward. NASA's Galileo spacecraft passed by Jupiter's frozen moon Europa in 2000, but the Juno probe recently made the closest approach in 22 years, offering the greatest glimpse of the ocean world since then. One of only 3 close-up views of the ice world ever, the 2-hour flyover passed just 219 miles, 352 kilometers above Europa's surface. The most recent observation of this kind came from Galileo on January 3, 2000. Tall shadow-casting blocks and other hard-terrain features can be plainly observed, and the surface is curved by bright and dark ridges and troughs. It's possible that the oblong crater next to the Terminator is an old impact crater. Officials describe Juno's unique perspective as essential to establishing observations for NASA's upcoming Europa Clipper mission, which will launch in just 2 years to explore the ice moon, even though geology data from the flyby is only now beginning to arrive. The Galileo orbiter, the Voyager 1 and 2 spacecraft, and earlier imaging missions of Europa have discovered the material that appears to have welled up from underneath has colored some of the moon's surface. The makeup of this substance will be examined by Juno's infrared camera and spectrometer to ascertain whether it is formed of salts or organic molecules. According to one theory, pockets of water can emerge below the surface either as a consequence of ice melting or as a result of liquid convectively rising through the ice shell, possibly as a result of forces put on the ice by Jupiter's gravitational tides. If there are any pockets of water near the surface, the MWR ought to be able to detect them. Controversial evidence for exploding water geysers that rise far above the Earth and into space is connected to the potential of liquid water nearby. Hydrogen and oxygen clouds in the shape of plumes were first spotted by the Hubble Space Telescope in 2013, and their potential silhouettes were later discovered in 2016. Galileo recorded slight alterations in Jupiter's magnetosphere near Europa, which could be the consequence of charged particles in the plume deflecting the big planet's magnetic field, according to scientists examining archived data from the satellite. Scientists discovered in 2021 that Europa was emitting enough water vapor to quickly fill an Olympic-sized swimming pool, but since water geysers haven't been shown to exist yet, it's still unclear how that water vapor got there. During its flyby, can Juno discover a geyser for the first time? It is unlikely. If the plumes are real, we need to be extremely lucky to fly past them while they are exploding, and in a location where we just happen to be watching. However, Juno may still see a geological feature on the surface that is generating water vapor, such as the tiger stripes on Saturn's ice moon Enceladus that have their own water geysers, even if it doesn't witness a plume in motion. As an alternative, Juno's navigation cameras will look for frozen fragments that are reflecting and scattering light as they slide back down to Europa's surface. Juno will approach Europa from a high inclination, providing the spacecraft its first views of the polar areas of the Moon due to its polar orbit around Jupiter, which involves passing over the North and subsequently the South Poles. Prior expeditions, in contrast, hugged the Moon's equator and concentrated on their equatorial areas. Due to Juno's orbit, this is also the only opportunity for the spacecraft to view Europa up close. Radiation is the main concern. When Juno reaches perigove, which is the term for its closest point to Jupiter, it will be exposed to a significant amount of radiation from charged particles that are trapped in Jupiter's powerful magnetosphere and frequently batter the surface of the planet's moons. Juno is designed like an armored tank with shields to withstand this radiation, but ultimately, our shields will no longer hold, to use Star Trek terminology, and the radiation will begin to damage Juno's electronics. Even though Europa may be Juno's lone chance, it won't be the last spacecraft to travel to Jupiter's ice moons. A recent study found that the underwater snow rises through the water from the global ocean and clings to submerged ravines and inverted ice peaks. The same mechanisms that exist beneath ice shelves on Earth may have an impact on how Europa's ice shell forms. Europa's ice shell could not be as salty as previously thought. Understanding the amount of salt in the ice crust is crucial for engineers preparing for NASA's Europa Clipper mission, which is set to launch to Europa in October 2024. The interplanetary spacecraft Europa Clipper was built by NASA to study Europa through a series of flybys while orbiting the gas giant. The major goal of the Clipper is to determine whether conditions favorable to life exist in the enormous ocean of liquid water underneath Europa's icy surface. Using cues from the ice shell, researchers may discover more about the salinity and viability of Europa's ocean. Europa's ice shell is estimated to be between 10 and 15.5 miles, 15 and 25 kilometers thick, and it likely sits on top of an ocean that is between 40 and 90 miles, 60 and 150 kilometers deep. Scientists are interested in the ocean's salinity and chemistry to establish whether Europa is potentially habitable or even the type of life that may live there. According to earlier research, the ocean closest to Europa's shell has similar temperature, pressure, and salinity to the water below the Antarctic ice shelves. The researchers looked at congelation ice and frazzle ice, the two processes through which water on Earth freezes beneath ice shelves. So what makes the difference? Congelation ice actually forms from below the ice shelf, whereas frazzle ice drifts up through extremely cold seas before resting beneath the ice shelf. When the researchers extrapolated their results to the age and size of Europa's ice shell, they discovered that salt water was even less salty. Both of these types produce ice that is less salty than seawater. There may be more crystalline ice on Europa than previously believed, which would result in a purer ice shell. Fragile ice can only hold a tiny fraction of the salt in seawater. The purity of the ice shell can have an impact on its strength, ice tectonics, and heat conduction capabilities. According to Donald Blankenship, a senior research scientist at the University of Texas Institute for Geophysics, we can utilize Earth to evaluate Europa's habitability, quantify the exchange of pollutants between the ice and ocean, and determine where water is in the ice. When built, Europa Clipper, according to NASA, will be the size of an SUV and feature solar arrays that cover an entire basketball court, making it simpler to power the spacecraft as it travels to Jupiter's icy moon Europa. The Europa Clipper will set foot on the Jovian moon in April 2030. Over the course of nearly 50 scheduled flybys of Europa, the spacecraft will gradually lower from a height of 1,700 miles, 2,735 kilometers over the surface of the moon to only 16 miles, 25 kilometers above it. In order to gather data about the moon Europa's atmosphere, surface, and interior, NASA said the Europa Clipper spacecraft will orbit Jupiter and conduct a number of close flybys of Europa. In addition to the depth and salinity of the ocean, its complicated payload will examine everything from the ice cap's thickness to the features of potential plumes that may be blasting underground water into space. It's important to know that Jupiter began its life by accreting rocky material just like every other planet in the solar system, even though today it may primarily be a ball of swirling gas. The planet's rocky core grew increasingly dense as more and more rocks were drawn in by the planet's gravity. This dense core began drawing massive amounts of gas from a great distance, primarily hydrogen and helium, left over from the Sun's creation to form the planet's massive atmosphere. But just how Jupiter managed to gather its first rocky material is the subject of two opposing theories. One hypothesis holds that Jupiter gathered billions of smaller space rocks known as pebbles, although these rocks are likely closer in size to boulders rather than actual pebbles. According to the results of a recent study, the alternative theory proposes that Jupiter's core was created by the absorption of numerous planetesimals, huge space rocks with a diameter of several miles that, if left undisturbed, might have served as seeds for the formation of smaller rocky planets like Earth or Mars. Which of these theories is true, nevertheless, has not been able to be determined with certainty up until this point. Because we cannot directly observe how Jupiter was formed, we have to put the pieces together with the information we have today, Miguel said, and this is not an easy task. Researchers needed to create a model of Jupiter's interior in order to attempt and resolve the controversy. Miguel said that seismographs were used on Earth to use earthquakes to analyze the planet's interior. However, she continued, Jupiter lacks a surface on which to mount such apparatuses, and its core is not anticipated to experience significant tectonic action. Instead, they combined data primarily gathered by Juno with a small amount from its predecessor Galileo to create computer simulations of Jupiter's interior. At various locations in the planet's orbit, the probes measured the gravitational field of the planet. According to the data, Jupiter is accreting rocky material with a high concentration of heavy elements. Since these heavy elements combine to form dense solids, they have a stronger gravitational pull than the gaseous atmosphere. The researchers use this information to map out the planet's subtle gravity variations, which help them determine where the planet's rocky material is located. Models developed by the researchers showed that Jupiter has substantially more heavy elements than predicted, between 11 and 30 Earth masses worth, 3 to 9% of Jupiter's mass. The pebble accretion explanation is unable to account for such a high concentration of heavy elements, which is why the new models suggest a planetesimal gobbling origin for Jupiter. The ultimate beginning of the gas accretion process, if the planet was large enough, would have instantly ended the rocky accretion stage if Jupiter had originally formed from pebbles. This is due to the pressure barrier that would have been generated by the expanding layer of gas, Miguel stated, preventing new pebbles from being drawn within the planet. It is likely that Jupiter had a far lower heavy metal abundance or metallicity than what the researchers predicted as a result of this slowed rocky accretion phase. The gravitational attraction on the rocks would have been greater than the pressure from the gas. Therefore, planetesimals may still have clung to Jupiter's core after the gas accretion phase had started. The researchers claimed that the planetesimal theory's simultaneous accretion of rocky material and gas is the only explanation for Jupiter's high concentrations of heavy elements. Another intriguing result from the study was that, contrary to earlier expectations, Jupiter's interior does not mix well with its upper atmosphere. The newly created internal model of Jupiter reveals that the majority of the heavy elements it has taken in have remained close to its core and lower atmosphere. In order for hotter gases near the planet's core to rise to the outer atmosphere before cooling and dropping back down, researchers had thought that convection mixed up Jupiter's atmosphere. If this were the case, the heavier elements would be more equally dispersed throughout the atmosphere. Miguel added that additional investigation is required to pinpoint exactly what is occurring inside the atmosphere of the gas giant Jupiter, but it's likely that some areas of the gas giant may have a slight convection effect. The discoveries of the researchers might alter the origin narratives for other planets in the solar system. Jupiter was the planet that had the most impact on the creation of the solar system, according to Miguel. The size and orbits of its cosmic neighbors were shaped by its gravitational pull, so learning how it formed has crucial ramifications for future planets, she noted. The discoveries also point to a possible planetesimal genesis for Saturn, Uranus, and Neptune, the three gas giants in the solar system. It's possible that additional gaseous planets in other star systems formed by consuming planetesimals rather than pebbles, which means they might have more metallicity than their outward appearance would indicate. Therefore, the researchers added, it's crucial that we don't categorize these new worlds by their clouded surfaces when we discover them with NASA's James Webb Telescope. And in other news, in what appears to be a new era of space exploration, NASA recently announced that it had chosen 13 potential landing sites on the Moon as it gets ready to send astronauts back there as part of the Artemis mission. With this mission, the first crew to return to the lunar surface since the Apollo missions of 1969 to 1972, the first woman and person of color will set foot on the Moon. It's really a new era of space exploration, don't you agree? Let us know what you think of these discoveries in the comments section below.